All right. So yesterday we kind of talked about the previous lesson, we talked about some fractional probability. And essentially, if we were like looking at the answer key here, the probability of getting a heart of any of these cards, you'll notice that there is one card that is a heart and then out of 8 total. So we put 1 over 8. And then the probability of getting a diamond, well, there's going to be 1, 2, and 3 that have diamonds. So we put 3 over 8. And then in talking about, some different things, a spinner, okay, landing on a 4, well, there's 1 4 out of 8 total spots. Landing on a 5, well, there's 1 2. So we'd have 2 over 8 technically, but then that would simplify to 1/4. And so a lot of these, which number is most likely to be spun? 3, because it has the most. So that is all, like most of these are going to be what we call theoretical probability. And so theoretical probability is going to be the actual probability of something happening. And so essentially when we talk about if we were rolling a die, a 6-sided die, there would be 6 sides. So the probability of rolling, a 6 on a 6-sided die would be 1 out of 6. And that's really not going to change. However, so the theoretical probability, we have that, and then we have experimental probability. And so this kind of how to explain this is basically by flipping a coin. And so we can kind of now compare the difference between theoretical probability and experimental. But again, the theoretical probability of flipping a coin and getting tails, that's going to be the actual probability. So in general, when you flip a coin, the probability of it getting tails, well, there's one side that's tails out of 2 total sides. So it would end up being, in general, we get 1 out of 2. And again, the theoretical probability is not going to change. So after 10 trials, if I flip a coin 10 times, the probability of getting tails is still not going to change. And so it doesn't matter how many times that I flip it, okay, the probability is going to stay the same. Okay, that's always, every single time I flip a coin, the probability of it getting tails is 1 out of 2, or 50%. All right, that's going to be the theoretical probability. So here's what we're going to do. Okay, I already did this, so I'm going to save you the time. And so we're going to talk about some of these outcomes. So notice that I did trials 1 through 10, and I basically just flipped a coin 10 times. And you'll see that I kind of counted, I had 1, 2, 3, 4, 5. I got tails 6 times out of 10. And so my experimental probability of getting tails, this is going to be based on all of my trials. So on my 10 trials, I got tails 6 out of 10 times. And so I'm going to simplify that to 3 over 5. Now that's according to my trials. Okay, if you did it yourself, you might have different trials. But according to mine, my experimental probability of getting tails is 3 over 5. However, my theoretical probability is always still 1 over 2. And so now we go, I ended up flipping it 10 more times. So I had 6 total, and then I ended up getting 4, 5, 6 again. So I have 6 tails. So that means it would be 12 out of 20 total. And my probability actually still ends up being 3 over 5. So I divide each of those by 4. And so then I can kind of figure out my experimental probability after 50 trials. So I had 12 after 20. So then I had 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28 out of 50 total trials. And then if I simplify that, I can divide them by 4. Ooh, I can't divide them by 4. I can get 14 over 25. And so essentially my experimental probability after 50 trials was 14 over 25. And just to put these into like percentages, okay, after 10 trials, mine was 60% of getting tails. After 20 trials, I got 60% chance of getting tails. And then here I can just multiply each of these by 4 because percents are out of 100. So I'd have 100 there. 14 times 4, we end up getting 56. So actually my percentage of getting tails after 50 trials ends up being 56%. Okay. And so notice that my experimental probability, what do I notice about it as the trials increase? Well, I had 60%, 60%, and then 56%. So it's starting to move. It's going to begin to go get closer and closer to the theoretical probability. And so the more trials you do, the closer it's going to end up getting to the actual probability. And so, if I did, 100 trials, something like that, my theoretical probability, again, it doesn't change. But based on my theoretical probability, how many tails would I get in 100 trials? Well, I know that would be 50 because the theoretical probability is 1 out of 2 or 50%. Well, according to my experimental probability, I would get 56 tails. And so we kind of think about, okay, well, what's the point of having an experimental probability if we already know the theoretical probability? Well, the experimental probability, we can apply that to a lot of different things. Not everything is going to have a theoretical probability. You'll notice that for a theoretical probability, okay, flipping a coin, rolling a six-sided die, those types of things are consistent and have a theoretical probability. But for experimental probability, we aren't so sure. So an experimental probability might be, the probability of, students passing a class, or different things like that, where it's not just, oh yeah, that probability is always going to be 40%. Because I'm willing to bet that if every single student in this class did this experiment, we might have some that have the same, but we would all get different experimental probabilities. And that's just, the way it works. Both are going to be important. Theoretical is going to be just the regular probability, probably the most accurate, but experimental probability relates to a wide variety of things. All right. And so that's going to be the main difference and essentially what you would do. So whenever it asks you, well, what's the theoretical probability of something happening? Okay, that's just the regular probability. But then the experimental probability is going to be based on those trials.